So when the arrow point upwards, it means that it's in tension. Okay, so for this case, stress X and stress Y, they are both what? Positive. And I'm going to say that stress X is greater than what? Stress Y. So it's standard practice that you label this as point X and then you label this as point Y. Okay, so this is what we call an element. And then on our right hand side, we're going to do Mohr circle. Okay, on the right hand side. So next on the right hand side. So on Mohr circle, as you guys have seen already, right? We have two axes. Right, we have two axes. So this will be our normal stress. And then over here is our shearing stress. Okay, shearing stress, element rotate clockwise, element rotate anti-clockwise. And we state that stress X is greater than stress Y. Both are positive. So we know that stress X. So this is our stress X line. Right? And then the other one, this one over here, is your stress Y line. Because the shear is equal to 0, right? So this is your point X. And over here, this is your point. Wait, what am I doing? And the other point is your point Y. Right? So from here, you know the center of the circle, location of center of circle, you can draw your Mohr circle. So this is the first circle. Okay. So for this case, there's a point, which is the center of the circle, like how I labeled before. All right. So the distance from here to here, this will be equal to our stress average. So for this case, stress average is equal to stress X plus by stress Y divided by what? Divided by 2. Okay. And remember, the normal stress X and normal stress Y are what? Vectors. Okay. So you have to include the sign. Some students forget. Okay, have to include the sign. Okay. So there are cases also. So this is one case. Okay. There's cases that we have seen just now in our loading situation. I'm just going to look at normal stress now. Okay. Later on, then I combine. So there are cases where you only have what? Where you have stress Y. Okay. So from here, we know that this is our point X and this is our point Y. So what we see over here is point X. When there's no arrow or anything, the normal stress is 0. Point Y will be equal to what? Positive. So once again, we construct Mohr circle. Okay, once again, we construct Mohr circle. So this is your Mohr circle. Normal stress. Then you have your shearing stress. Right? Shearing stress. I'm always driving you guys in that this is positive. Shearing stress where the top is element rotate clockwise, below element rotate anti-clockwise. I'm always enforcing it for that reason. So we know that stress X is at your 0 line. Now stress Y is going to be positive. Okay. So when you construct your Mohr circle, you look like this. Right? So from here, if you were to look at our stress average line, which is center of the circle, All right. So the distance from here to here, this is our stress average. So for this situation, right? For this situation, we realize that stress average is just equal to stress Y divided by what? Divided by 2. Okay, like our problem earlier. But that's not always the case. Okay, if you have stress state at X and Y, you have to get stress X plus stress Y, then divided by 2. Right, so what we realize down here, anything that is on the right hand side of the vertical, everything is in tensile. Everything on the right hand side is compression. So in terms of sign, this side is positive, over here is negative. So let me quickly give you an example. So we have another situation now. Okay, we have another situation now where you have stress X and then you have stress Y. Right? So when it's pointing towards the element is what we call compression. When it's pointing away from the element is what we call what? Tensile. Okay, so for this case, stress X is negative, stress Y is what? Positive. So now we were to construct our element now. Okay, so this is our normal stress. Again, then we have our shearing stress. Element rotate clockwise, element rotate anti-clockwise. Then we have our lines. So this will be our stress X because it's in compression. And then we have our stress Y in tension. Like what you can see down here. So you have your stress X, stress Y. I think I have to label this point as 0 so it's more clear there to you. So again, again, we have to label this as your point X. Okay, so this will be your point X. This is your point Y because you have 0 shearing stress. So over here will be your Y and over here will be your X. So from here, you can construct your Mohr circle. And your Mohr circle is bigger now, right? Then your strength. Now you look at the circle is bigger now, but your shear stress is the average stress is the smallest. Interesting, eh? Right? So this is where you draw now. Right? So the stress average is always from the 0 point. Right? So for this case, you know that stress average is equal to stress X plus by stress Y divided by 2. Okay? So this is your normal stress. So you just found out how to move from element to construct your what? To construct your Mohr circle. Okay, so that's normal stress. Anyone, any question? Is this straightforward? Yes.
Eugene, how does constructing the Mohr circle help you in like choosing your material? Like we have like some have greater stress average than others, like in terms of like your Mohr circle. What do you get from that? What's the understanding?
The average stress cannot be used for the average stress cannot be used for selecting material at all. It just tell you where the center of the circle is. Okay, so like sometimes, okay, I don't usually use this, but sometimes if you have a material that is no good in tensile, okay, you by just looking at the stress average, you say, hey, this will not work. For example, concrete, right? Brittle material are very bad in tensile loading. So by calculating the stress average, I don't need to go any further. I'll say, oh, my stress average is positive 100 megapascal. This is a very brittle material. It's ceramic. It cannot stand tensile loading. So I stop my analysis. Does that make sense?
Yeah, makes
Okay,
sense.
that's the only way that I'll use it. But if in terms of material, proper material selection, we are going back to our principal stress. Okay, everything we look at our what? Our principal stress. This is because of the data that we are given. Okay, because the data that we are given is either in tension, right? It's either in tension or it's in shear. Okay, and we are not given a combination of both tension and shear together because it's too expensive to do such tests, and no one is going to pay for the expense for of doing tests like this. Okay,
So
right.
Eugene, there are four principal stresses, right?
Say it again.
There are four principal stresses, right? Left, right, up, down for the
No,
tension and shear.
the principal stress is when shear stress is zero. So you only have two principal stresses. Okay, so over here, let's look at our original problem. Okay, so over here, stress one.
Is there a label for the maximum
Shear.
shear?
No, we just call it maximum shear.
Okay, thanks.
Okay, we that's not our principal stress. We just call it the maximum shearing stress, right? So when we look at maximum shearing stress, when we look at handbook like this, we have to make sure that it's below the what? Below the allowable yield in terms of shear. If not, your material will fail in shear. Okay, and what you see, this is dangerous territory. What you see is in the shear is less than what? In tension. And it makes sense. It shows over here, right? If this is 200, right? If this point, this is material 200, over here will be what? Half. Yes or no? 100. That's why it's lower based on Mohr circle theory. Okay, that's why it's lower. That's why you look at this 260. This is 150. The shear is always lower than what? In tension. That's why later on we're going to design the structure based on maximum what? Shearing stress. Not always based on normal stress. Okay, the material is going to fail. The material is going to fail in shear first. Okay, right. So what we have been through now, I've just relayed to you on Mohr circle regarding normal stress. Okay, so normal stress is very straightforward. No one get confused. Now the next one we're going to work on based on shear. Now shear is where a lot. Even me, I got confused in terms of shear when I was younger. Okay, but not anymore. Okay, and I don't want you all to get confused. So let's look at shearing stress. Okay, so let's look at shearing stress. Wait. Somehow my pen is playing up. Sorry. Let's look at. Wait. Is someone controlling my computer? No, right? So let's look at shearing stress. So shearing stress, there are two types of shearing stress. Okay. There are two types. There are two types of shearing stress. So let me view. So one is known as positive shear. Okay. So if we were to draw positive shear, this is how it looks. Okay. So this is positive shear. Right? And then the other one, and I'll draw the center of our element. I'll elaborate later on. So this is the center. So this is your X. This is your Y. And then the next one we have is negative shear. Okay, so we have negative shear, and it looks like this. All right. So the problem that we had earlier is what we call negative shear. or the element A. Remember the element A that we analyzed with negative shear. So the same thing. I'm going to draw my element here. Okay.